Okay, my friends, I am going to have a wonderful time. I hope you do. If you are a geek of any sort, you are going to enjoy the heck out of this. Now, I am totally against the Bohr model. It does not work. It never worked. In 1970, I wrote a paper saying this doesn't work. And because everything has to be a dipole. You can't have a gigantic positive in the center and one tiny, tiny, tiny little negative out there. It does not work. The core, in other words, what they're saying is the core of every atom has one big giant ball in the center that's positive. And then maybe in a hydrogen case, you have one in the center, which is called a proton, and you have one tiny, tiny, tiny little electron. Well, the electron only weighs 0.000544, and a proton weighs 1. That's ridiculous. It's impossible. It's crazy. And they're the same charge, and one wouldn't get sucked into the other one. That's crazy. So let's forget this. Bohr model's gone. That does not work. This is what does work. What does work is this model right here. This is the core of every atom. And every atom, instead of this in the hydrogen, is this. And it's 1,839 of these little particles, which we would call electrons. But they're dipoles. They're not just negatives. And your whole ball of them together makes a proton. If it's an uneven number, it will be attractive to another electron. It will want another electron to bring it up to 1840 to make it a neutron, neutral. Everything wants to be neutral. So it will attract and give and so forth. And at a certain point, there'll be so much attractiveness here that it will draw in more electrons, and it will hold them in a quantum state surrounding that core. And we're going to talk about this because I got to the point where he talks about the standard model, and I realized, ooh, this is going to be fun. All right, let me give you a quick demonstration of the nucleus of all atoms. In the center, you see a big positive charge. Right? It's a good size, heavy-duty positive charge. Around it are all negative charges, which are attracted to that positive charge. So it's basically what I showed you before in my little diagram here. Hold on. Right here. So basically what we have is this right here. The dark in the center, surrounded by the whites. Only it's a complete ball of them. Instead of just being a flat plate, it's a ball like this. All right, now, there's so much negativity attracted here. They don't want any more negatives. Watch what happens when he tries to introduce another negative particle, which is nothing more than a positive and a negative at the same time. It's not just a negative, because none of these are just negatives either. They're negatives and positives together. We just see it separated because of the way he laid it out. But it would be just like this. Now, one more of these wants to come in. It's not allowed because there's so many surrounding the darkness in the center already. It can't come in. And we know we can do that by pushing. You see? It's pushing away. That means there's so many already around here that it wants to push this one back away from it. Just exactly what you're going to see happen here. Now watch this. All right, so he's got three big... Anyway, watch what happens when it comes close. Boom, there's quantum right there. You just saw quantum happen in front of your face. That is the nucleus. This is another dipole electron. It's coming in and it's trying to snap in there. This negative trying to get into that positive in the center. These negatives push the negative away. So what will happen? This negative wants to be in there. So the negative side will face there and the positive side will face out. More electrons will come. They'll want to get into the positive side of this facing out, but there's so much negativeness is in here that will stay a distance away from that one. And then they'll start to form orbitals. But they're all being made from these particles here. There is no gigantic nucleus. The nucleuses are made like this. And the smallest nucleus there is a hydrogen, which is approximately 1,839 electrons in a mass. And then one more is influenced by that mass, just like this one is. Now, that one will stay attached. Watch what happens. He's jiggling around. It's going to stay attached. It's going to no movement. Now, that is the natural. Everything that's just sitting here is in this condition where it's just attached. Everything's fine. Nobody's getting hot. Nobody's excited. Nobody's pushing and shoving, and there's no light, and there's no heat, and there's no burning. And all of a sudden now we're in a whole different situation. We're getting hot. We're getting real hot. We're burning. Boom. Particles are flying. Light is flying off. Electrons are flowing. Electricity's moving. Boom. Done. All right, just so we fully understand each other, when he gets to talking about the standard model, they always said that there's electrons, there's protons, and there's neutrons. Well, an electron is this tiny, tiny, tiny little negative charge, and it weighs, like I said, a bazillionth of the weight of a proton. But in hydrogen, that proton is supposed to have one positive charge, and the electron has one negative charge. Well, first of all, they would slam right together. A negative is going to, there's no reason for it to stay at that distance. They can never account for that. The only way they could was some mathematical gymnastics that just never worked. It's just impossible. So but that's what their model was. And then they just kept adding more and more neutrons and protons and saying, well, that means there's more and more electrons out here in a cloud. Well, in some respects, yes. In some respects, no. Here's the respects, yes. The cloud is there, yes. But it's only there in a quantum states because it's trying to get in, and the inside is pushing it out because the inside is a dipole, and it has more push than these have shove to get in. So the push out is more than the shove in. So they surround that core. And here's how it works. The core, the dark part of the core, and I will show these particles in great detail. They look exactly like what I showed here. Hold on, here it is. It's exactly identical to that. That's identical to the particles that are light. Identical. There's two blacks and two whites. The white ones are glowy and they can get bigger and smaller. They're pushy and shovey and hot and burny. These are cold and solid like bowling balls. They're called these fixed particles. And Fermilab does. They call the black one a fixed particle, and they call the white one a point particle. It can go big, it can go small. The fixed one is just fixed. And this is exactly what I've shown. Exactly identical to what I've shown. Now, to my theory of how those point particles and fixed particles, which is really what an electron is. To us, it was always an electron. But we never saw the dark part. That's where dark matter is. That has almost all the weight, and it may have all the weight. And the white one has almost no weight, but boy, is it a hot little bugger. Now, what happens is the black ones are attached to the white ones, but they don't mind being on top of each other. The white ones hate each other, so they want to get away as far as they can. So they surround on the outside, and always the center will always be the black. It'll be pushed to the center. That's why we've never seen it. It's always on the inside of the white. All we can see is the glow. We know that there's mass there because things pass by it and they're attracted to that, yes. This one wants to get into that black desperately. And I'll show you this in a quick little toy, and you'll see quantum physics in action. The core is a heavy-duty positive sucker. These negatives are sucked in, and then they coat that gravitational black matter. When they coat it, they'll reach a point where it's almost like an equilibrium, and they'll say, no more can come. And this guy says, well, I want to come in here. He says, no, you can't get in here. He says, well, I want to get to that black thing. And he says, no, you can stay 10 angstroms out there. That's it. Don't come any closer. That's what's called quantum. Now, if you have more and more and more in here, it will attract more and more and more electrons. And say, no, you stay there and one over here. And then the next time it'll say, one here, one over here, one way out here, one over here, one over here, way. And they will set up patterns surrounding this. I'll show you that right now. And then we're going to go into this talk about quantum. Because this is all about quantum, the magic of quantum. There's no magic. It's this magic to all the physicists because they don't understand dipole flood theory. Okay, this is the standard model. All right, And they consider all of these to be basically elementary particles. Well, there's really only two elementary particles, which I have found, and there's a black one and a white one. Now, I can only use these two colors, but what it is, the boson is the heavy jobber. This is the really, it has almost all the weight, and it carries the fermion. The fermion is the glowy, exploding part, which we would always call an electron. These are the tiniest particles there are, and everything is made of those two particles. So once you start adding these up spin, down spin, I'm going to show you all these things and what they are and how they weigh and all of that. I've shown it over and over. Very simple, and that's the only two particles that exist. And when you put them together in a configuration like that, two dark ones and two white ones, you end up with a photon. In configurations like this, they're electrons. Okay, each one of those is an electron. You put them together and you have a photon. If each one of those was by itself, bzzz, it would burn into you. It does not want to be by itself. It wants to be part of a greater mass. That's why when you walk around, you get static and all that on you, and then you touch a water pipe, pew, they jump right out of you to try to get to that water pipe. And all they are is electrons. They're not light. They are electricity. That's what static electricity. Lightning, same thing. Light coming from the sun and a flashlight, that doesn't burn into you. It might warm you up because it's bouncing your electrons, but it's not incorporating into you normally. It's a bounce away from you. That's how light works. Electricity, whole different story. It goes right in and incorporates right into your pretty much water. It wants to go into water, hydrogen, oxygen, H2O. Now, let's look at what these particles really are and what they show in the standard model, which is not correct. And then we're going to go into this conversation, because it's time to have a conversation about electron flood theory. They're never going to figure anything out. There's nothing. Well, hold on. I think there's something up here I can show you about what doesn't work, which is almost everything. Well, here it is. Although the standard model is believed to be theoretically self-consistent, has demonstrated huge success in providing experimental predictions, it leaves some phenomena unexplained, falls short of being complete theory of fundamental interactions. It does not fully explain baryonic symmetry, incorporate full theory of gravitation. There's no gravitation theory whatsoever that works with it. It really doesn't work with general relativity anymore. The universe acceleration expansion is possibly described by dark energy, which they have no idea what dark energy even is. All of that stuff doesn't work. Not a single bit of it works. And it's because there is no such thing as a gigantic positive and a tiny little negative. That right there, my friends, is not workable whatsoever. The only particles that exist is the muon neutrino and the electron neutrino. Everything else is made up of those particles. And they will never see that, because what they're doing is hitting head on gigantic billions of particles at the same time, protons. They're hitting these on like this, and every one of these is 1,839 of these. And they're using billions at a time, hitting them head on with each other and splashing these particles everywhere. What we did was we took light, and we shot light through a venturi and watched the light itself split. That's how we got our particles. All right, just to back myself up, I did this. I was in the Army in 1968, and I was in Nike Hercules missiles, and I got into, atomic physics and all that stuff, and I wrote papers on the fact that there was no such thing as the Bohr model that worked, and that everything had to be dipoles, which is 100% dipoles. All right, which is quite obvious. I think I have shown you that. Now, was going to show you this for some reason. This is all gobbledygook, really. Oh, I remember now. Look at this. Gravity. Despite being perhaps the most familiar fundamental interaction, when you drop something to the floor, it falls. Gravity is not described by the standard model. They have no idea why it happens. It's due to contradictions that arise when combining general relativity, which doesn't work, the modern theory of gravity, and quantum mechanics. You cannot do it with the big particles they have. However, gravity is so weak at microscopic scales that it is essentially unmeasurable. Oh man. The graviton is postulated as the mediating particle. 100% of every interaction is literally magnetic, electromagnetism. Gravity is nothing more than the dark matter that is more attractive than the white matter. As you build bigger and bigger and bigger, you get more and more dark matter, and it overwhelms the white matter, so it tries to take in more particles. But again, the shell of the outside of the mass, which is an Earth or whatever it is, an atom, doesn't matter. It says, I have enough. You can come down. Now, in the case of the Earth, there's so much attraction that, yes, it'll go right into the Earth, and that's why everything goes, it's called Earth ground. It sucks electrons in because it's so strong. And as it gets bigger and bigger and stronger, you end up getting in a black hole where just nothing gets out. Right now, we can bounce light out and all that stuff. But if we get so big as a black hole, it'll just poof, and go right in and never get out. So this explains 100% of everything. This explains 0% of everything. Our nucleuses are particles. Now watch this. This is a place called Bruspup. Very, very good. And this is the resonance experiment. Resonance means vibration. Zzz. Now this is a metal plate. And as I told you, every single thing there is coated with electrons. When I say that, what I mean by that is, let's look at that plate one more time. All right, here's the plate. The dark matter is inside. We're never going to see anything but electrons. All right, there's electrons on the bottom too. And in between is the dark matter. That's always, 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 always. We will never see inside that white matter. Now, what does that mean? Those are the pushy ones. Those are the ones that push. The white ones, they want to push the other white ones away. If we vibrate this with electricity, all it does is push up and down, up and down, up and down. What does that do? We got a negative, pushing negative, 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 negative. The whole thing is going negative, negative, negative. So what does that do? Whatever's up above it has to go, if it's a negative thing, it goes up. Negative to negative, negative to negative, negative to negative. Well, salt is a polar molecule, so it has a negative, very strong negative dipole. This is a strong negative dipole as well, because the white is on the outside, the other part of the dipole is inside, so it's going up. So the white is going up, this white has got to go up. And that's exactly what happens when they put salt on here. Salt is NaCl. Both sides of the periodic table. This has 7 extra electrons, that has 1. That's why this is so positive and this is so negative. That makes it a polar molecule, salt. So now they're going to put salt on this table, and then they're going to start to shake that table, vibrate it. And here's the frequency. You see that little wave there? That means they're going, woo, shaking this. And at first they're going to just vibrate it. See, they're going to vibrate the plate by using a tone generator. As the pitch of the tone increases, the patterns get much more complex. Now they're starting out where we would start out with hydrogen, and it almost looks like it would be hydrogen. I'm going to stack it when it gets, you see this? At this exact frequency, 345 hertz, that cycles in every second, we get this pattern, which would be really hydrogen and helium. Helium, you've got 4 spots where you could have orbitals and 1 center core. Then you go up to the rule of 8. Watch how elegant this becomes. The next pattern shows the rule of 8. So this one here, it locks into 345. Now we're going to go and add some more salt, and they're going to vibrate this one. And look at this, 1033. That is the most elegant rule of 8 I've ever seen. 1, 2, 3, 4, 5, 6, 7, 8. And that is what surrounds, and that's what's called the rule of 8. And after that, they all are supposed to have 8 in their furthest out orbital to become stable. And here's I just keep going through them. See, look at this here. 1, 2, 3, 4, 5, 6, 7, 8. And they, you can almost find it in every pattern. They're all over the place. 3, 6, 8. And they start to glob in different ways as they get bigger and bigger and bigger. And then, some of them you lose track of how it's all. But look at the patterns. And these are all different frequencies, 48, 40, and they get more and more complicated the higher up you get. And at a certain point, they get so complicated that they just don't want to stay together anymore. They start to fall apart on their own. And that's at the very end of the periodic table, where you get plutonium and uranium, and they're ready just to fall apart. And if you just crush them, boom, they'll pop. Okay, this is a Venturi that is designed to accelerate light. It's something Rod Warren and I stumbled on 6, 7, 8 years ago. And it's pulsed red laser coming through a completely black surrounded background, so that anything that has energy, we can see their luminous value, which is nothing but particles that are in the air. As this pushes through the air, this glows because it has energetic push to shove, same with this. In this black background, we can see it. Now, at this point, we've made the Venturi up here 2 round entryways with a finely tuned slot, and that forced the light to accelerate. A Venturi is fully understood to accelerate. It's called an atomizer. It atomizes gas in a car, in old cars. And this is where we are atomizing light. We literally took the light and made it show up just like this before it literally exploded into atomized or photonization. Instead of atomization, it's photonization. And how did it happen? Right here. Just like the same Venturi that was in the old Cadillac. And here's what happened when it hit the Venturi. It separated. The black particles came away from the white. That's fission. Cold. We didn't add any extra energy whatsoever. And that's fusion coming back together. There's 2 pins here. And there's a very, 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 very thin slit. And the white can get through and the black can't. And the white can get through because of this characteristic. It is not a fixed particle, but the black is. You see the black right there? That's called a fixed particle. It never changes. There's another one right there. It has a little glowy edge around it, and it's just a fixed particle. These are what they call point particles, you see? Fixed point particles. We're the first ones to see these. I think Fermilab predicted them. I had something that showed Fermilab. Here it is right here. They predicted them. The Fermilab predicted the fixed, and they said it's a fixed particle. Now, these don't exist. It's only one size that I can determine. The green and the red are identical. Blue is kind of fast. We really can't see it, but I'm pretty sure it's going to be the same one. It's just that it's spinning much faster than the red and, the green. But the point one is this one, see? See, it can glow big, it can go small. So I go along with these. They can get big, they can get small. That one never changes. That's the size, and it has that little glowy thing around it, see that? And that's from Fermilab. So I feel pretty confident that we are showing that particle, and then we actually separated it, as I showed you, the fission and the fusion. And once again, that's not my doodle right there. That is from CERN or Fermilab, and I think both of them. They want a muon and an electron neutrino, the black and white balls attached together, which I showed you. And at the Venturi, they split. Now, they have them coming head on and hitting and just splashing things all over. And they see these particles. They don't know they were ever really in the configuration I show them in as a photon. Because the standard model shows all kinds of particles. I mean, they got they call it a particle zoo. They do. They call it a particle zoo. Atomic zoo. There's so many little variations. Because once you take something like this, there's 1,839 in just one proton. You take millions of them, billions, and they slam together. They just got tons of crap everywhere. How are you going to ever make any sense of that? All they can do is keep looking until they find the smallest ones. And they found them. They're there. No question whatsoever. But I can make them go right through the tunnel, and we can collect them right over here. And I think we get free energy. And I think we can do it right with this right here. There's some work to do. Figure out how to make a transition metal receiver right there. All right, we've already done the fission and the fusion. In between, if we can harvest that raw energy, I think we're golden. I think that's 200 times more energetic than when we started. And if you look at the pictures, you can actually see, you can almost not even see the particle. And then all of a sudden, you got this. That's literally, and not kidding whatsoever, that is an atomic, subatomic explosion. That right there is a subatomic explosion. You see the energy? This is the reverse EMF, electromotive force, coming back. Look at that. Look at the increase in energy here. They say it's 200 times more energetic if you can do what we did, which was split the particles apart. Now you saw them split right there. The black ones don't go, the white ones go through, the black ones don't, but they recombine right here. Zoom. Fission, fusion. I don't see any other way to look at it. All right, he's going to be talking about building particles up to make something. They're going to talk about quantum Legos. And what I showed you was taking light and literally splitting the particles apart. Now they have to come back together. Are they going to come back together as light? Or is there a way that we could make a frequency like I showed you how as they come back together, and we put in 1083 hertz and it comes out as helium or hydrogen or whatever, instead of coming out as light? I think we might be able to do that. Once we have them in that condition where they're black and white particles, if we can make some kind of frequency to shake the white ones back and forth until they're at that frequency like I showed you with the salt, I don't see much of a difference there. And if somehow you can lock it there and it stays, you've got hydrogen. Or you lock it there and it stays and you have gold. I don't know what you could do with it. There's a lot to think about coming through that Venturi. If those particles are in their raw, most elemental particles, which they are, you should be able to build anything out of them if you can put them back together correctly. They're going to want to come back together as electrons and light, because that's what they were before. And we can see them come out as the Higgs fields. Let me show you that. Alright, I showed you the Venturi where the light was coming through and splashing. Well, it's coming directly at us. Alright, and these little white sprits, you see these little white sprits? That's the white field that was just nothing but raw electrons. We can see right through it. It's a little glowy like, but then all of a sudden these particles slam into reality and they begin to create these Higgs fields. That's the Higgs fields. These are supposed to be the God particles. Well, we got them coming out of our ears. Now that one there, that is the killer. That, I believe, is a reverse spinning particle. They all have what they call a right-hand spin, which throws the electrons out. It throws the electrons out. And as it does, it bounces the other, and they push them in so they make a circle. This one is coming in. It's pulling its electrons into itself, I believe, and creating that white particle. That's the only one I've ever seen like that. And let me show you what happened when it hit one of these Higgs fields. It was the strangest thing I've ever seen. Well, this is the other strangest thing I've ever seen. These are the Higgs fields manifesting themselves after the white. This one got pinched by a couple of extra fields coming in from the sides. Turned it blue. Squirted it out. You see how it elongated the plate, the Higgs field? The field is now like squirting out like a tube of toothpaste, and then it turns back into a different color again, and it will come back to red. This is kind of an interesting interaction. Now let me show you the other one I called a mini trumpet. Okay, This one here threw me for the loop. I have never seen anything like this, and I have probably thousands of pictures from Rod, and Rod was tireless at doing this. Now, this particle, I believe, is that white particle. And again, they come in different pictures, so I can't be 100% certain, but I do believe that's what it was. And that white particle here has some form of a characteristic, a look to it. And I believe it was there and there. Because these pictures take a whole batch of them at the same time. Still the same particle. So that particle is the same particle as this particle as that particle. Because it takes a whole batch of them at the same time because it's so fast. So, this came, boom, it hits against here somehow. It interacts and bleeds off this. Now, where that will go, I don't know how bright it will get. It's gone brighter. Anytime the leading edge is here, anytime you see the glow of a glow, the glowery the glow, the more close to that pushing forward it is. So this is glowing pretty good here. But that's all I can tell you about that. I have no clue. I would say that's got to be an anti-particle. It's not just a reverse spin. Because, I have up spins and down spins coming out of my ears, but that's the only one I have one of those. See, I believe they would call that an up spin. The glowy one is up. This one's a down spin. Same particle. They do a flip. As the top one charges up, sooner or later it'll go flip and the bottom will come in front. And then that'll charge up and it'll flip, 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 flip. Now, I don't know if they flip around that way or they flip this way. But before they are getting charged up at the Venturi, you don't even see them. Then all of a sudden they start to show up, then they do this, and then they explode. That's the manifestation of that. And I'll show you the green one because I'm telling you, I believe that black particle never changes. See, that's the same particle. The exact same, only they're much, much faster, the green, and they impact much harder than the red. But it's the same particle. No difference. And just so you know, I'm not teasing or kidding. You see how weak that is compared to that? Whew. And it reconcusses way out here. The red is toast this far out. And it was just pushed out of the way. And they're the same particles. Alright, this one went a little bit a different way because the green is just so powerful. But you see this side? Not a single black particle. None. Zero. All the black ones are going this way, see? Over here, you just have, that's just burn. That's raw energy, raw energy. This is starting to concuss already here. Because these are heavy jobbers. These buggers are hammer. They just hammer. And, there's a little work to do thinking about this, but that's a Venturi. And the other one, we could see the Higgs feels nice on both sides, just perfect. And Rod had that one just dead center. This one's just a smidge off. So we know those. We can separate the green or the red. Doesn't matter. There's not a single black here. Not one single one. I looked at this very carefully. Not a single one there. Zero. Okay, on the other side, they're all there. Over there, not a single one. But that is, you can see it's like a glowy sort of heavy-duty energy. All right, that's what this stuff is. It's just a really heavy energy. I think there's just a ton of energy there. All right, so I have shown you what I have shown you, the particles, the black and the white particles. Well, let's talk about dark matter. Dark matter is a component of the universe whose presence is discerned from its gravitational attraction rather than its luminosity. In other words, it does not glow, it does not reflect, it does not radiate, it is dark. It's dark matter. Dark matter makes up 30.1% of the matter energy composition of the universe. The rest is dark energy, 69.4%. And ordinary visible matter, which is the white particles I've showed you, is only a half of 1%. So I showed you these particles. There was a black one and a white one. The white one turns into showers. The black one stays exactly the way I showed you. And the black one is 99.5% of the mass. Well, what is mass? Mass is the thing that can push you. The other 0.5% is the burn part. Burn doesn't push. Burn just burns. Black pushes. The dark matter is a bowling ball pusher. Can I prove that? Absolutely. Hello, my wonderful friends. This is really, really serious. What if I told you I could do a nuclear explosion in my garage? And I have, and so has Rod Warren. We have done nuclear explosions in our shops. And here's what we did. Exactly what this atomic bomb will do. I'm just going to play this. This is a test house. What they're going to do is send off an atomic bomb. Now, the first thing when that atomic bomb goes off, all you see is whiteness. You say, well, what is that? Well, that's light. I don't see the house moving. Let's keep playing. Here we go. Boom. All of a sudden, what are we seeing now? It's just burning. I don't see the house moving. Do you? Let's keep going. I got it running pretty slow. I see the house just combusting. I don't see it moving. Do you? It's just burning. All of the flammables are just literally combusting off. I don't see the house moving. Do you? This is the nuclear explosion. Where the hell is the explosion? Well, guess what? Here it comes. Because it follows the white particles. Now, look, see what happens. Boom. Well, why is the thing burn and now it's being pushed? Because they're two separate particles being exploded from that core, which was the atomic bomb. The first one is just a burner. And I can show you that. We did it. And the second one is an exploder, and we did that too. And now watch what happens. Because the dark particles, which are the exploders, are still sitting back at the tarmac, they've lost all those white particles. They're the first ones to go. They just go easy. They're just pushers. They push them like crazy away. And then the black ones follow them, but not all the black ones. So now there's a pile of black ones back here to say, I want those white ones to come back. And here they come. Watch what happens. This will turn right around. It's turning around. And it's saying, okay, let's go back. Because the guy's missing us. Boom, there it goes. Okay, so you're saying, Roger, you must be insane. You're talking about setting off a nuclear bomb inside your house? This is not a nuclear bomb. This is an atomic bomb. Well, it is a nuclear bomb, because it's breaking up nucleuses and causing this kind of chaos. But I am doing a subatomic bomb, meaning that I started with light. So I'm not in the atomic realm yet at all. Atoms are huge compared to light. Light is just like almost seems to be virtually nothing, and they don't even know what it is. They don't know if it's a particle or a wave or it's a the standard model doesn't work. The Bohr model is totally wrong. So let me show you my a subatomic bomb that I created here. Rod Warren discovered it. And then I was able to do the same thing here. Anybody can do it anytime you want. It's very, very simple. And then we should be able to harvest this kind of energy. This doesn't knock your house down. That just puts a lot of energy into something. Think if you could use that energy that you see right here. Well, you can see what it does. Running that through wires, you could power a city. Look at that. All right, then comes the concussion of the black particles, and I'm going to show you this exactly in our atomic blast. Here we go. Subatomic, I'm sorry. All right, now I'm going to explain to you exactly what they did and exactly what we did. They took a huge mass of particles that was so unstable that it wanted to fall apart already. And then they exploded it inward, which made it blow outward. So here it's just really nothing. It's just sort of a really powerful source, but it's not doing anything. Now, then we exploded this right here. Boom. Well, not really. We shot it out. Same thing, because boom means shoot out that way or this way, this way. So it goes all directions. We forced it into concussion at the Venturi, identical to the atomic explosion, only we are in the subatomic realm. We are splitting light particles, not atomic particles, not atoms, not huge chunks. And here's what ended up happening. As the particle accelerated into our Venturi, which is a known accelerator, it's called an atomizer, and we see it accelerate. I don't know how you can miss that. And you see an enormous increase in energy, and you see a division of the particles, the black and white particles. Only the white comes through the Venturi. The black cannot get through because it's too big. And here's those particles right there. That's just prior to them dividing. And when they did divide, they created exactly like that white energy we saw burning the house. Here's the house burning. All right, here's the house burning. The black balls, we created a device that won't let those black balls come through. Let me show you the device and what happens here as they concuss. Don't forget, these are the particles, the black and white particles. And then, bam, they hit against the Venturi. The blacks can't get through, the whites can. We separated them and did exactly what I showed you as that house started to burn. This is the burn. But we got it so that the blacks can't get through at all. So we should be able to harvest this white right here, and the blacks can never get through. So in an atomic bomb, boom, they come through instantly afterwards. Ours, they can't get through. I'll show you. And we could do this all day long, because that Venturi separates them. Hold on. All right, you saw the two particles, the white ones and the black ones there. This is what they are. This is a fixed particle, never changes size, has no absorption of energy, no emission, no radiation, no reflection, and it cannot change size. It's fixed. These two can glow and get smaller and build up power, and they burn like hell. Look at them, they're glowing. These don't burn, they're cold, but they push. These are 99.5% of matter is the black part. This is almost, as you saw, it hit the house and just burned it. Didn't do anything. There's no concussion value. There's literally no mass to these that I can determine other than that glowy. You know it's something's moving out there because, and it's ahead of these. They have separated in the which we can separate them too. I didn't show you that yet, but here it comes. We separate them just like CERN and Fermilab have by hitting them head on, but we did it through the Venturi. So we created fission here to separate them. Instead of just concussing them, letting them go flying and hoping for the best. We concussed them and forced the little white ones. Remember the white ones were tiny, the black ones I said are big and fixed? They are the same size everywhere. They just, that's it, they're like bowling balls. And the white squirts through. The black can't get through. Simple as that. Fission, fusion. And this right here is literally a nuclear explosion. This is a nuclear explosion. Why is it nuclear? It's because it's in the nucleus. It's a subatomic. It's not atomic. It's not big things exploding, big chunks flying here and there to knock your head off. This is, and then they come back together instantaneously. So here's the key. The Venturi is right here. All right, so this, the slit is right here, and it's just exploding as it hits, and it's just crushing these particles through. We need a thin film receiver right in here somewhere that takes that vapor, this atomic hot vapor, and just filters it down to do whatever we want with it. I don't know whether burn something with it or store it as electrons. Because as far as I'm concerned, these are free, extremely energetic particles at this point. And all their purpose in life is to get back with that black one. So if we can put something in between this and getting back to the black, we should be able to use whatever energy is here, and it seemed to me like there's a lot of energy. All right, so as I claim, we did a subatomic nuclear explosion. And this is the particles it created, these Higgs fields and all of the muons and electron neutrinos and all of that business. Now, and these are actually pictures of that event occurring. Extremely high energy luminosity, which causes the CMOS pixels that are picking this up to be able to see it as radiance and luminosity. They use the same things. These are in smartphones. They use the exact same things used as cosmic ray detectors. I mean, nobody has any better technology than this. So don't tell me we can't see it. We can see it because it radiates and it's luminosity. It's not like we're just looking down at an electron that's just sitting there. No, these are illuminating. That's why we can pick up the luminosity. Now, this is the new model, which is my model of dipole electron flood theory, which means every particle that exists is a dipole, and they all turn into electrons, which will be a positive and a negative, basically attached together. So the electron is not just an electron. These are the neutrinos, they call them. We never saw anything except the electron part. This is the dark matter. It literally is the dark matter, and it's 99.5% of that particle. I agree with that. These particles have mass, and they can move things because they're not separated. And so we see it as light, and it can push. Light can absolutely push things, and it can burn things and all that stuff if there's enough intensity to it. And they're made out of these electrons, but light normally comes in a photon. Lightning, static, electricity, that's your electrons flowing independently. Photons flow through the air, attached to each other, and when they impact with something, they bounce. Right? They don't incorporate. These do. Just like lightning, static, electricity. They want to get to ground, literally to the earth ground, because the earth has so much of this black matter that it wants all of these white ones. The white ones want to get to that black. Take it either way you want. The black seems to be stationary, like the Earth's core has a huge amount of blackness to it. And that's 99.5% of mass anyway, so these want to be attached. So that's why everything goes to the ground. That's gravity. All it is the muon is the sucker, and the electron portion is the electron neutrino portion is the pusher, burner, and all that. So this is gravity. That's gravity. You can't even, they don't have any idea what causes gravity. I'm serious. You ask a physicist what causes gravity. No idea. Zero. The Bohr model has no idea, because it's all contradictory when you get to gravity. It says, ooh, nothing else works if we take into account gravity. Yeah, forget gravity. And I'm not kidding you. They said, it has such a small attractive a force that it doesn't play any part. Are you kidding me? Drop 100-pound cannonball on your foot and see how little attractive force it has. All right, so let's go to the next level. I say there is nothing that exists that is made of anything other than these two particles together. We know we can separate them. I showed you them separating. The black can separate from the white. That I thought was unbelievable. But we have seen it. No question it happens. There it is right there. All right, there it is right there. I've shown it very, very completely, so I don't have to screw around with that anymore now. So we know that these are the only things that exist. So what is energy? What is energy? It's free electrons. And what are electrons? Electrons to me are both the black and white particle together. That's what an electron is. All right? They call them electron and muon neutrinos, and the two of them together make up the electron. So what can we do with these electrons? How do we get them free? Because that's what we need, free electrons for heat and light and energy and all that stuff. Well, we know we can create heat, because all free electrons are heat, 100% right across the board. Anytime you see something glowing like this, that is the signature of an increase in temperature, basically. All right, it's an increase in energetic value. Energetic value to me is temperature. There's nothing other than temperature. Push to shove. When you push electronic fields together, they create heat. That's why when you get electricity going through a wire, it gets hotter. The more you put it hotter and hotter. Sooner or later, it'll burn up. Well, let's talk about the different electron interactions. That's all there is. All right, that's all there is. There's nothing more than electrons. They turn into balls, which are protons, and they seem to be stable at right around 1839, 1840 electrons in a ball like this. And when it hits that, boop, it sort of locks in, and that's the smallest stable ball of these electrons, and it's called hydrogen. And here it is on the periodic chart, way down here. And that's called a 1. And they say it's one of these, big gigantic proton, and one tiny, 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 tiny little electron. They say that electron's so small we don't even care about the weight of it. It's 0.0005845, something like that, of what one of the nucleuses was, of the hydrogen. But this really is what it should be, not that big ball. It's 1839 makes that proton, which is the nucleus, and then one more wants to still get in there because it's still attractive to one more. But that one is said, no, you stay out there away from us. You can stay 5 angstrom units, whatever it is, but you can't get any closer than that. And I've shown that. Look up tractor beam magnets. You will see exactly how a core of an atom is constructed. It's just exactly identical to the core of an atom. And then the electron tries to get in, and boop, it pops up just at a distance away, and it says, no more, we're done. We're fully coded, you cannot come in here. He said, well, what do you want me to do? Stay right out there. Stay just a hair's breadth away from us. And sooner or later, maybe one of us will leave and you can come in. And that actually does happen, because the nucleuses are changing all the time. They say, well, the nucleus is one big solid chunk. No, it's not. Ever hear of isotopes? Isotopes means you got a chunk like this. It should be 1800 well, they think it's 1839 or 1840, whatever. But they say that's 1. No, it's 1839. And if you lose 1 or 2, you can go 1837, 1840, 1842. Those are called isotopes. There's one that's completely stable, they say, and that's the one that has exactly the right number of electrons, and that one won't want to take on anymore or give any up. The rest of them are what they call ions. They're isotopes, and they have pluses or minus charges. They'll either want to get rid of some more or take some more in to become that particular one that is exactly correct in the middle. That's what's called half-life, the ones that aren't exactly correct. Now, let's go into the different types of energy. All right, just to give myself a little credibility here, I did all the data on this. So this was all different heat reactions, heat of reaction, heat of solution, using calorimeters and different mixtures and different salts and acids and what temperatures drifted and what, and everything came down to, after I got all the data done, everything always came down to electricity. Once you started to work out the details, everything came to all power is electric, 100% electric energy in joules. There is nothing but electric energy. And then, anyway, I did everything. This was my paper on dipoles, and everything was dipoles. There was nothing but dipoles. And then that's about resonance. Let me find the thing here. It's magnetic properties. There's two types. It's all dipole to dipole interaction. There is nothing but push to shove. That's what I always call it. There it is right there. Transfer of energy is from light to atomic vapor. I wrote that in 1970. Rutherford's atom was wrong. Bohr's postulates were wrong. And again, I didn't do just one day of this. I did everything. I did all of the different... I worked everything out myself to be sure that I was right and they were wrong, and I was right and they were wrong, and they're still wrong. And I'm still right. How's that? And like I say, I just want to give myself some credibility. I'm 100% This is all about light energy. I did everything. I took energy, 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 energy. Millikan's oil drop experiments. I checked everything that they were saying. Was it right or was it wrong? A lot of it was right. I'm not saying everything was wrong, but the conclusion that there's a huge positive chunk in the center and one little tiny electron didn't work. Absolutely no way in the world it could work. Dipoles are the only thing that exists. And again, I did all the work, so I feel pretty damn comfortable talking in this realm. All right, so you know my claims that every single thing there is made of electrons. So the only thing we can get for free energy is free electrons. Free electrons means free energy. Now, to get them free, how do you do that? That's hard, but it's easy. We did it just by putting them through the Venturi. Now, there's other ways. There's chemical release. We know that when things bond together, like cements and things like that, you feel heat coming off them. Well, that's because when they take two little atoms or molecules together, sometimes they'll bond together and they'll have excess electrons left over. That's the heat. It's just letting them drift out of there. Now, so we have chemical release, where things come together and they give off extra electrons. Then we have impact. And if you just slam something hard against something else, it'll get hot. You go bam, 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 a couple times, you feel it's hot. It's impact, it's field push, it's everything there is has a magnetic field around it because they are all these electrons. There's nothing but them. So they all have a magnetic field. You push against that field, it creates a little bit of heat. You push real hard against it and it pushes back, and there's enough of them pushing back and back and back. You get a lot of heat, and that's, you know that because of the way electricity works, you can generate huge amounts of heat and have fires. So it's the field push, basically, and when it pushes, at some point they'll expel electrons. If you take a wire and you hold it near a water pipe, an electric, it'll go right down because it wants those electrons into the ground because the ground wants them, and the wire doesn't. So now, there's electricity is static. It's lightning, and it's regular electricity like we see in the electric wires. Now, static is nothing more than extra electrons that are in the air floating around attached to normally water molecules. And as it gets drier, there's no water for them to attach to it, so they will collect on you. That's why you get static cling in a dry environment, because the electrons have no place to go, so you're pretty attractive, and they collect on you. Now, if you can't discharge them to ground, if your shoes are like leather soles or that type of stuff, they will just continue to collect on you, and you'll become basically a capacitor. You'll have a capacity of electricity built up in your body, and when you touch ground, something that has a place for those electrons to be absorbed, it can be a big metal object, or it can be something that gets into the ground of the earth. It will just suck them right off you, and that's when you get that's static. Then of course there's lightning. Those are just free electrons too, and they're so collected in the atmosphere from the scrub. Just like if you took wool and you scrub, you on a glass rod, you see sparks come off, basically electrons, because it's pushing the fields back and forth. One of them has a positive charge, the other one has a negative charge, and they literally push the fields off and create electricity. So that's what static, lightning, electricity is. We see it, the aurora borealis, all of that stuff. It's push to shove of fields. That's all there is in this type of heat and energy. Now, so that's heat, and heat cannot create. Oh yeah, to do heat, to create fusion, they can't create enough excess heat. They can't create, whatever heat they put in, they're only going to get that same heat back. They're never going to get above that. Although fusion, when I say fusion, I'm talking about the fusion I'm going to show you where the light well, here it is right here. It separates here, fission. It comes back here, fusion. This is different than what they're doing. They're taking huge molecules, all right, of particles like hydrogen that have a whole lot of electrons that are sort of just hanging in there, and then they hit them with some radiation that forces them to be released, and then they fuse back together and create a molecule that has a smaller mass to it, so it frees up a whole batch of electrons. That's what their type of fusion they're doing, which is good if they could do it, and they might, but we can do it right now by fission of light. We're doing fission of light, and it looks to me like it increases the value of that particle 200 times, because that's all they're getting to the same thing. By the time they're done, they're just releasing electrons, which is the white particles. Basically, that's how I'm seeing it. I could be wrong. I could be totally wrong, but somebody's going to have to look into it. So anyway, my bottom line is we use a Venturi, which is solid state. You could do it right in a little grid, little box. You carry it around like a shoebox. No grid. You just plug whatever you want into it, carry it around, plug it in, turn it on. You wouldn't even hear anything. You wouldn't hear a sound. You just go, electricity come out. Portable, self-contained, no grid, subatomic, which means it's not going to explode. There's no real danger whatsoever. It's controllable. It's clean. There's no expansion of the gases. 100% electric, and this we can do within a couple of weeks if somebody would take a look at this. Let me put it this way: if this can be done, which I'm showing you, and I say it can be done, and if it can be done, we will know within a couple of weeks to a month tops. If it can't be done, go on about your life. If it can be done, things would be pretty nice. And this was all you really need to do, basically. Is if it works, it works. If it doesn't, it doesn't. That's all. We separated those particles at the Venturi. I showed you that happening. All we used was a very low wattage laser, say 5 watts. Coming out of here, we should have 200 times that wattage of energy. And you could see an enormous, gigantic glow of energy. Now, can we harvest that energy? I don't know. If we can pull it down and put it into our own little battery packing system, and it could be done in something as small as this. All right, you could carry that around in the woods, go anywhere you want, and have any kind of power you want. 60, 50 cycle, 60 cycle, AC, DC, 120, 220. And this is a Geiger counter. I'm just showing this to show you how simple this device would be. And it wouldn't have to be any bigger than that. I can't imagine it would have to be any bigger than that. Lasers are just tiny, tiny, tiny little flat things. And this is going to be tiny, tiny, tiny little flat thing. This distance is almost nothing. And you'd have to have like banks of them in there. And then you'd create all that kind of excess energy and plug right into it. As far as I can see, that it would be simple as that. And if this is that kind of power, 5 watts could give you 1,000 watts. That's pretty reasonable. And you know, the cost of this equipment is like zeroness almost. It's just absolutely, bottom line, cheap. And once it's built, it's solid state. I don't see it ever having to do anything at all. You put these in cars, you just keep driving. If I'm right, because you just keep repowering your laser by a little bit of the excess that you've given off. If you can increase the value of what the power that you need for the laser, if that laser draws 5 watts and you can get more than 5 watts harvested, that means you have a net increase. All right, so you can scale it up. Now, you should have an enormous net increase. Solar panels, they're just laying there and they're picking up sunlight that's hitting it and everything. But they're working pretty good. I was watching a show this morning. The guy it cost him $60,000 to put it on his house. And he was getting bills of $500 a month. And now it's $10 a month after he put them on. So that's pretty good. Now, the grid people that own the grid are saying, no, you can't do that. You're using our grid. And you're not contributing anything. You're taking all your energy and selling it back to us at full rate, basically, is what it's deducting from their bill, let's put it that way. So they're using the grid when they need it. So they have to have the grid, but they're not contributing to the cost of the grid. So they want them to make payments in addition to their investment. So the guy invested $60,000. Now, he's down to $10 on his bill from 500. They may want him to pay another 50, 60 bucks or whatever he would have normally paid, which would have been associated to the grid on a $500 bill. All right, because it's most of the, well, I don't know how much of it is. They may want to charge him 50% of what he was paying, so he might want another 250 bucks a month from him to cover the grid. I have no idea. But these are the kind of things that come up. Now there's no grid. I don't have to use your grid. I can go in the woods with that. I can build my cabin and go out and get the hell away from society. I already am, but but I can't get too far away from the grid.